Now that we learned about some important basics of React, most importantly about components and props, it's time to take the next step. And in this course section, we're going to take a closer look at user interaction and handling user events like clicks or input into text fields and so on. And we're going to have a look at the very important concept of state in React apps. Because you might remember that I mentioned earlier in the course that with React we follow that declarative approach where we in the end define desired target states and React then takes care about reaching that state. Well, that is correct and that is already something we're using, but at the moment in the application we built thus far and with the knowledge we gained up to this point, we can only build static applications where the state never changes, where we always output exactly the same. And that's typically not what you want. You want to have applications which are interactive so that you can react to clicks by the user and to data being entered by the user, and which are reactive so that the application also changes when certain things happen. And therefore, in this course module, we are going to take a look at handling events, handling user events like clicks and so on. And we'll see how that works in React apps, how we can add such event handlers and more. And then we're going to take a look at how we can ensure that what's visible on the screen changes, that we reach a different target state. And for that, we're going to take a closer look at this state concept in React, and we'll learn how we can manipulate the state and transition from state A to state B if we want to. And in general, in this section, we're going to learn about a couple of key concepts. This is a section you absolutely should not skip. And we're also going to take a closer look at components and state again. So this is another fundamental section covering core features of React. So let's dive in. So this is our demo application at the moment. And of course, it's fairly static. We have this output here on the screen, and we reach that output with help of our components, but as I mentioned, this never changes. It's static. We only have one state in this application, and that's this initial state which we see here. Now let's dive into how we can react to user events before we then have a look at how such events could trigger a state change. And when we want to start with events, I want to start fairly simple. I want to start with clicks on a button to which we want to react. And to get started with all of that, I'll go to the expense item where we output the title, the amount, and so on. And in there, I will also add a button below that div right before we close the card. And there, I will just say change title. And if we now save that, we will see this button here. Now, the styling is definitely not great, but this is also just a temporary button. We're going to remove it later. I'm just using it here so that we can start diving into events and state. Later, we'll use what we learned in better places, in places that really help our application. But for a start, we now have these buttons, one per expense item component. And my goal now is simple. When this button here is clicked, I want to change the title which is being output here. Initially, the title which is being output is the title we get via props. But I want to change it whenever this button is clicked. And therefore, we of course, first of all, need to find out how exactly we can react to button clicks in React. And it turns out that this is rather simple. On all built-in HTML elements like divs and h2, and especially also buttons and so on, we have full access to all these native DOM events which we can listen to. So if you search for HTML button element, for example, you'll find an article about this button. And there, if you click on the DOM interface here, this HTML button element, you see from which other elements or from which other classes this inherits in the end. And here you see that the HTML button element is a more specific form of the HTML element, which is a more specific form of the element, which is a more specific form of the node, and so on. And if we click on element, for example, we actually will see that there are a bunch of events to which we can listen. For example, click and blur. And basically for all these default events, there is a prop equivalent in React, which we can add to these built-in HTML elements to listen to these events. So instead of adding a listener as we would normally do it, by, for example, selecting an element by ID and then adding an event listener like this, which would be the imperative way of doing that, in React we add an event listener by going to the JSX element, like this button, and there we add a special prop. But now it's not a prop which sets some value for this button, but instead it's a prop which starts with on. Because React exposes all these default events as props which start with on. And for example, here we can add on click. Now what this does is it adds an event listener for click events to this button. Now we just need to define what should happen when such a click occurs. And we do that by assigning a value to this click event. And the value here, and that's now important, of course has to be code which should be executed when that click occurs. And how do we define code that should eventually be executed in programming? Well, we create a function. So all these on props, all these event handler props want a function as a value. A function passed as a value for onClick and all these other on props, which then is executed when that event occurs. Now here we can either create this function on the fly, for example like this. We can create an anonymous arrow function like this, and then here we could console log clicked if we wanted to. And if we save that and we go back and open the developer tools here in the browser, and there we go to the console part, if I click the title, we see clicked. So this is how that works. This is how simple it is to add an event listener to a React element. Now, typically you don't just want to work with such anonymous inline arrow functions though. By the way, it doesn't have to be an arrow function. You could also create a function with the function keyword. You don't want to overdo it, at least, because it would mean that you put a lot of code here into your JSX block, into your JSX code, and that's generally not a good idea. You want to keep that lean and not put too much logic into your JSX code. Instead, you typically want to define a function before you return, and you can do that either with the function keyword or again by creating a const or a variable which holds an arrow function. So here we could add a click handler const, the name is up to you, which holds an arrow function like this, and in there I can also say clicked with a couple of exclamation marks. And then here for this button, we just point at click handler. And that's important, by the way. We just point at it. We don't execute it here. You don't add parentheses here. Instead, you just repeat the name of the function, no matter if you created that function like this or with the function keyword. This does not matter. No matter how you define it, you just point at it like this. Why? Because if you would add parentheses here, JavaScript would execute this when this line of code is being parsed. And this line of code is being parsed when the JSX code is returned. So it's then not executing click handler when the click occurs, but when this JSX code is evaluated. And that would be too early. That's why instead we just point at the click handler, we just point at the function, we pass a pointer at this function as a value to onClick, and then React basically memorizes this and executes the function for us whenever the click occurs, so that it's not executed when this is evaluated, but when the click occurs, which is exactly what we want. So now when I save that and I reload here, you see now we have clicked with multiple exclamation marks, which is the console log from this const. And that is how we can add event listeners to our elements. To all these built-in HTML elements, we can add supported event listeners basically. OnClick, for example, basically is available on every element. Some events are only available on specific elements, but that is all based on the default DOM behavior. If an element supports an event, then you can add a listener with React by adding such a on and then the event name prop. Just make sure that the event name starts with a capital character, like in the case of onClick here. And then you just point at a function, either defined inline here or better defined up front, and React will execute that function for you when that event occurs. That's how you add events. Now, one word about naming these functions. It is a convention which you don't have to follow, but which you might consider following, that you name your functions like this if they are triggered upon an event, that you end with handler. This is not a must-do, and not every React developer does it, but it is a preference I personally have, and you will see it in a couple of projects out there, so that it's clear that this is a function which is not called by us somewhere else in our code, but that it is a function which we attach to an event listener so that it's eventually called by React when that event occurs. That's why I'm naming my event handler functions like this, ending with handler. But again, this is just my preference. You see it in a couple of projects. You might want to consider doing that, but you don't have to. But now with that, we know how we can react to events. How can we now change what is showing up on the screen though? Reacting to events is an important first step. How can we now change what shows up on the screen? Well, we want to change the title when the button is clicked. So here's one thing we could do. We could create a variable with let, which we maybe name title, and initially that holds the value we find in props title. And then we use this title variable down there in our JSX code to output the title. Now if I do that, we see the same result as before. So why am I doing that? Well, since it's a variable, we could change it whenever this click handler executes. So whenever this button is clicked, we execute this click handler function, and in there, if we now change title to updated, then we should see that changed title on our screen, right? Because we're outputting title down there, we're changing it up on a click, we should see that value here in this place after such a click happened. Well, let's save everything and give it a try. If we go back, you'll notice that if I click change title, nothing happens. I can hammer this button and nothing happens. This title here never changes. So why is this happening? Is something wrong with our click handler? Well, this function is getting triggered. I can prove this. If I console log the title here after we changed it, you will notice that if I now go back and reload, if I click change title, we see that updated title text here. So it looks like it worked, the click handler clearly executed, and title clearly was changed. Otherwise, we wouldn't see that new value, which we assign here in line 13, once we log it in line 14. So if the function executes and the title is changed, why don't we see that reflected in our DOM? After all, we are outputting the title down there in line 21. Well, simply because React doesn't work like this. And that's where I now have to dive into how React actually parses the JSX code and how it considers that and how it brings it onto the screen, though I will have an even deeper dive later in the course. But there's one key thing which you have to know right now. Keep in mind that your component is a function. This is a function, right? Your component is just a regular function. The only special thing about that function is that it returns JSX. Now, since it's a function, someone has to call it. And you might notice that we never called our component functions. Instead, we just use these functions like HTML elements in this JSX code. Well, the thing is, under the hood, this is almost like a function call. By using our components in JSX code, we make React aware of our component functions. For example, here, we make React aware of the expense item function. And whenever React evaluates this JSX code, it will call these component functions. And these component functions then return JSX code, which is also evaluated, up until there is no more JSX code to be evaluated. So React keeps on calling any component functions it encounters in JSX, then calls any functions that those functions might have returned, so any elements those components might have used in their JSX code, until there are no more functions left. So in the case of expenses.js, if React encounters this expense item, it calls this expense item component function, executes all the code in there, encounters this JSX code, and calls this card function and this expense date function. And then it goes through the JSX code of these components until there is no more component code left to call. And then it evaluates the overall result and translates that into DOM instructions, which renders something like this on the screen. That's how React works. Now it's all started by the index.js file, where we initially point at this app component. That's the first component function which is being called, and that happens when the React app is being loaded on the screen, which happens when the page is being visited. So that is how React goes through all these components, executes all these component functions, and draws something onto the screen. The only problem with that is that React never repeats that. React goes through all of that when the application is initially rendered, but thereafter it's done. However, in modern applications, of course, you sometimes want to update what's visible on the screen. For example, because a button was clicked and that button should change some text which is being output. So we need a way of telling React that something changed and that a certain component should be re-evaluated. And that's where React introduces a special concept called state. State is actually not a React-specific concept, but it is a key concept in React as well. And here in expense item, we have a scenario where we want to use that built-in state concept. Because this title here, which changes when the click handler executes, is actually data that should result in this component being re-evaluated and redrawn on the screen when it changes, when that title data changes. And by default, regular variables like this one are not triggering such a re-evaluation. React doesn't care about that. If you have a variable in your component function and that variable changes, React ignores it. It doesn't care about that. That code executes, sure, but the overall component function doesn't execute again just because some variable changed. And as a side note, even if it would execute again, of course then title, this variable, would also just be recreated and reinitialized to the props value, because as part of this component function, we are creating this title variable. So even if that would happen, we wouldn't reach the desired result, but we don't even need to think about that because it is not happening. This expense item component function currently is not called a second time after the initial rendering. Just because a click occurred or because a variable changed does not trigger this component function to run again. So to tell React that it should run it again, we need to import something from the React library. And we do this by adding a so-called named import. This here is the default import. Now we can add a comma and curly braces, and between the curly braces, we can now extract specifically named things from the React library. Here we import the overall React object. Now we want to import single pieces from the React library. And we want to import a function here, a function which is called useState. This is a function provided by the React library, and this function allows us to define values as state, where changes to these values should reflect in the component function being called again, which is a key difference to the regular variable we're using here. Now, how do we use this useState function, though? Well, it's very simple. Inside of our component function, and that's important, we have to do that inside of this function, we just call useState. And useState is a so-called React hook. There are other hooks as well, and of course we are going to learn about all important hooks throughout this course, but that is one of the most important ones. And all these React hooks can be recognized by the fact that they start with the word use in their name, and all these hooks must only be called inside of React component functions, like expense item. They can't be called outside of these functions, like this, and they also shouldn't be called in any nested functions. They must be called directly inside such component functions. There is one exception, which I'll talk about later, but for the moment, that is what you should keep in mind. Now, useState doesn't work just like that. Instead, useState wants a default state value. Because with useState, we basically create a special kind of variable, you could say. A variable where changes will lead this component function to be called again. And of course, we can therefore assign an initial value for that special variable, just as we're assigning a value here for this regular variable. So here my initial value is props.title, and we simply pass this as an argument to useState. Now this special variable is created. Of course, we also want to be able to use that variable. We want to be able to use it down here, for example, and therefore useState also returns something. It gives us access to this special variable. However, it does not just return that. It also returns a function which we can then call to assign a new value to that variable. So we'll not be assigning values like this with the equal sign. Instead, we will be assigning new values by calling a function. That's just how this state variable thing works. And for that, useState actually returns an array, where the first value is the variable itself, you could say, the value itself, and the second element in the array is that updating function. And we can use a modern JavaScript feature called array destructuring, which looks like this, to store both elements in separate variables or constants. And here I'll use constants. And I'll come back to why it's a constant in a second. Now you can choose any names of your choice, because for array destructuring, it's just the order which matters. And I'll name this title and setTitle. The first element, as I just said, is a pointer at that managed value. So initially at props_title, the value stored in props_title. And the second element here is a function which we can later call to set a new title, hence this name which I chose. Both names are up to you, but the convention is to use something which describes the value as a name for this first element, since that is the value, and then set and then that name repeated, just with a capital starting character here, this capital T, for that function which updates the value. That's the convention on how you name these two elements returned by useState. And useState, this hook, always returns an array with exactly two elements. That's always the case, and it's always the case that the first element is the current state value, and the second element is a function for updating that. Now with that, we can remove that title variable, and we can also remove that value assignment in ClickHandler. And we can still use title like this down there in JSX. So if we now save it like this, we still see toilet paper here. So that hasn't changed. But of course the button still doesn't do anything because at the moment we're never updating this. Now, as I said, with the value returned by useState, we're not going to assign a new value with an equal sign. Instead, we assign a new value by calling setTitle. So by calling this state updating function. And then we just pass the new value as an argument. In this case, updated. Now, why does it work like this though? Why do we have this state updating function instead of assigning a new value like this? The reason for that is that calling this function does not just assign a new value to some variable, but that instead this is a special variable to begin with. It's managed by React somewhere in memory, and when we call this state updating function, this special variable will not just receive a new value, but, and that's important, the component function in which you called this state updating function and in which you initialized your state with useState will be executed again. And that is exactly what we need. We want to call this component function again when our state changes. And by calling this state updating function, that's happening. Because by calling this function, you're telling React that you want to assign a new value to this state. And that then also tells React that the component in which this state was registered with useState should be re-evaluated. And therefore React will go ahead and execute this component function again, and therefore also evaluate this JSX code again. And then it will draw any changes which it detects compared to the last time it evaluated this onto the screen. So if we now save everything, if I click change title, you see the title changes to updated for the expense item in which we're doing this. And that's now how this works. Now you will notice that these console logs still show the title before it was updated. The reason for this is that calling this state updating function actually doesn't change the value right away, but instead schedules this state update. So in the very next line thereafter, this new value isn't available yet. That's why we see the old value being logged even though we updated it before logging. But you do see that eventually this component is called again and is evaluated again, and that therefore we see our updated value on the screen. That's how React State works, and this is another key concept in React. If you have data which might change, and where changes to that data should be reflected on the user interface, then you need state. Because regular variables will not do the trick. With state, however, you can set and change values, and when they do change, React will re-evaluate the component in which the state was registered. And only that component, by the way, not any other components, just this component in which this state was registered. Now let's take a closer look at this state and why we use const and how this all works in detail. So now we learned about state, and state, as you can probably tell by now, is a key concept in React. Now there are a couple of things I want to clarify about useState and about why we use a const here, for example. Now first let's start with one important thing which I did mention in the last lecture already. useState registers some state, so some value as a state, for the component in which it is being called. And I want to be even more precise here. It registers it for a specific component instance. For example, expense item here is being used 4 times, right? In expenses.js, we have 4 expense items. Now, every item receives its own separate state, which is detached from the other states. We have one expense item definition here, but then this function is basically called 4 times when we create 4 expense items. And every time it's called, a new separate state is created, Of course, in the same way, but managed independently by React. So if we change the title in the first expense item, the other ones are not affected because they have their own state. That's really important. It's on a per component instance basis. So we have separate states even if we create a component more than once. And that's of course crucial because it would be a rather undesired behavior if we change something in one item and all the other items are updated as well. So that's a good thing to have. Now, in addition, whenever state changes, because we click a button in this case, it's only this component function and only that specific instance where this component is being used where React will re-evaluate it. And you can tell that this is the fact if you add another console log here in the component function itself, where you say expense item evaluated by React. This will be called whenever the expense item component function is being executed. And therefore, if I reload, we see it's called 4 times. Which makes a lot of sense because we're using expense item 4 times in expenses. So 4 separate instances of this component are being created. But if I now click on change title in one of the expense items, we see it's only printed once. Which is basically happening because of what I just explained. Only that specific instance is being updated and therefore being re-evaluated, and the other instances are not affected by that state change. And that's important to keep in mind, that state really is separated on a per component instance basis. Now there's one other thing which could be confusing, and that's the fact that I'm using const here. Why am I using const here when we do eventually assign a new value? Well, keep in mind that we're not assigning a value with the equal sign. That would indeed fail, but that is not how we assign a new value when we update a state. Instead, we call this state updating function. And the concrete value is simply managed somewhere else by React. By calling useState, we tell React that it should manage some value for us. We never see that variable itself. So therefore, we just call a function and we never assign a new value to title with the equal operator. And therefore, using a const is absolutely fine. How do we get the latest title value then though? Well, keep in mind that the component function is re-executed when the state is updated, and therefore, of course, this line of code, line 9, also is executed again whenever the component function is executed again. So if we call setTitle and we assign a new title, that leads to this component being called again, and therefore this new title, this updated title, is fetched from React, which manages this state for us. Basically, we go to React and say, hey, please give me that latest title state which I told you to manage for me. And React provides us this latest state in this array, which useState always returns. So we always get a brand new snapshot of that state when this component function re-executes. That's how this works under the hood. Now you might be wondering if that doesn't mean that we always overwrite any state changes with props title again here. And here the special thing is that React keeps track of when we call useState in a given component instance for the first time. And when we call it for the first time ever, it'll take that argument as an initial value. But if a component is then re-executed because of such a state change, for example, React will not re-initialize the state. Instead, it will detect that this state had been initialized in the past, and it will just grab the latest state, which is based on some state update, for example, and give us that state instead. So this initial value is really only considered when this component function is being executed for the first time for a given component instance. And I know that this is a lot of knowledge about state, and it might be confusing to a certain extent. It is just important to understand how state works under the hood, because if you don't fully understand that, then you will run into problems in more complex React applications where suddenly some value isn't updated as you expected it to be. That's why I'm explaining this in great detail. In a nutshell, using state is simple though. You just register state with useState. You always get back two values, the value itself and the updating function. You call the updating function whenever the state should change. And you use that first element whenever you want to use the state value, like here, for outputting it in the JSX code. And React will do the rest, and it will re-execute the component function and re-evaluate the JSX code, therefore, whenever the state changes. That's state, and that's an important concept, because it's state which adds reactivity to our application. Without state, our user interface would never change. But with state and with listening to events, we can make sure that we can react to user input and that such input can result in a visible change on our screen. So state is a super important concept, and of course being able to listen to user events is also important, as you can tell. Now that we know what state is, and now that we also understand how we can listen to events, we can continue working on this application and turn this more and more into an expense tracker. And one important piece is missing, for example, well, the capability to gather user input, so that users can add their own expenses. This sounds fairly important for an expense tracker, and up to this point, it's not possible. So that's what we'll work on next, and for that I will first of all add new components, and I'll add a new category of components, you could say, because thus far the expense components we have here are about outputting expenses, about showing these expenses here. Now I want to gather user input, and therefore I'll add a new subfolder in the components folder, and I'll simply name it new expense, because ultimately that will be what the components here are about gathering the input for a new expense. And therefore in here we can add a new expense.js file, which will hold the new expense component in the end. And inside of this new expense component, I want to render a form where users can enter their expense data. So here I'll add the new expense const, where we have our component function. And of course, I export new expense here to make it available. And we can import React from React. As I mentioned, you technically don't need to add it. I covered this in the last course section, but I will still add it here, since you will see that in many React projects. And I want to again make it clear that JSX under the hood uses this React library. Now, as I mentioned, the goal with this component is to return a form in the end, a form for our inputs. And I also want to provide some styling around that form. So I'll first of all return a div, and then inside of that div return a form. Now, speaking of styling, we can also add a new expense.css file, and you find that file attached. You can either just paste in the styles you find there, or simply replace your new expense CSS file with mine, and then of course make sure you import new expense CSS. And that's all something you learned about in the last course section. That's all not directly related to state or user input, of course, but we'll get there. So now that we got this imported, let's add the new expense CSS class to this div, and let's now work on the form. And actually I'll take that form and put it into a separate component, just so that the form logic lives in its own component, and this component is really lean again. Not something you have to do, but something I will do here, and I did talk about splitting components in the last course section as well. So we can add an expense form.js file, and in there create an expense form component function like this, and then of course also export that function expense form like this. And if you want, import React from React, even though it's not technically required. And I'll also set up some styles. So I'll add an expense form CSS file, and you also find that file attached, and you can replace yours with it. And then, just as we saw it multiple times, import that CSS file, the expense form CSS file. And now here in the expense form component, I will return this form element, and in there we'll then structure this form. Now, when it comes to structuring the form, for gathering expense data, I want to let users enter a title. I want to let them enter a date or pick a date with a date picker. And of course, users should be able to enter the amount. So we'll need 3 input fields. And for styling reasons, I'll put every input field in a div, where the div has a class of new-expense __ controls, or to be precise, that's actually a div which will hold all inputs, but then I'll create another div in there with a class of new-expense __ control for a single input, and in there we can now set up a label, for example title for the first input, and then add an input of type text like this as a self-closing tag here in React, because these input elements don't have any content between the opening and closing tags, so we can and should write it as a self-closing tag in React. Now that's how we can create a first input here. And of course, these are all just default HTML elements, nothing React specific here. But we're soon going to add listeners to wait for user input, and we're soon going to manage some state with that. So this is some crucial groundwork which we have to do first. Now we can copy this div with the label and title and duplicate it to also have an input for the amount. The type here could be number, and we could set a minimum value of 0.01 and set up a step of 0.01 as well. And these are just default HTML attributes for input elements, which control how this element can be used. And last but not least, I'll replicate the div one more time to also provide an input for the date. Set the type here to date, and this will then automatically give us a date picker. And I will also set up a min date and set this to January the 1st in 2019, and add a max date, which I'll set to 2022 and there December 31st. And I'm picking this min and max date because later we also want to add a filter where we only provide the years 2019 to 2022 for filtering. So I want to make sure that these are also the only years expenses can be set to. Of course, you can play around with these values. These are just some example values I'm working with here. Now we got all these inputs, we now also need a button to submit the form. And therefore, right before the form closes, I'll add a new div next to the other div, which holds the controls. And in there, I'll add a new expense actions class like this, new-expense __ actions. And then in there, add a button where we say add expense like this. And I'll set the type of this button to submit, so that when this button is pressed, since it's inside of this form will be submitted. Now that was a lot of work on the expense form. Now we can use the expense form in the new expense component. And therefore we of course want to import our expense form functional component, so this component function. We import this from newexpense.js without the file extension like this, and then here we can just render this and add it as a HTML element in our new expense function body, so that the new expense component will render the expense form component. That should be expense form, of course, my bad. So expense form is being rendered here, and now I want to render this entire new expense component in the app.js file, because in there, in the end, we're combining all these components. So here I'll import new expense from /components/new expense/new expense. That's the path to this new expense JavaScript file. And then here, finally, instead of this dummy h2 tag, we can render new expense like this. If we now save this, this doesn't load because I have an error in the new expense JavaScript file. I'm importing expense form from new expense. That's of course not correct. I should be importing from expense form. That's where this component lives. Otherwise, I create an infinite loop, and that's this page, that's causing this page not to load. Now this works after changing this and restarting the server and revisiting localhost 3000. And now we have this form here at the top, which is great. Now we added the component, but the component is not doing anything. My next goal is now to make sure that we gather the inputs the user chooses here, maybe on every keystroke, or basically whenever the value in one of these inputs changes, so that we can, for example, log this to the console for a start. And that then as a next step, when the form is submitted, we step in our code and we take these gathered input values and combine them into a new expense object. So let's now work on gathering user input. And as I said, for a start, I want to react to every change in any of the inputs. So for example, on every keystroke, and I simply want to get the value the user entered and store that somewhere. And for example, just log it to the console. Now, to do that, for a start, we need to add listeners to listen for every keystroke or for every change of these inputs. And you learned that you can do that on the element where you want to add a listener. So for example, on this input here, by adding a prop that starts with on, and then the question just is to which event you want to listen. Now we could listen to on input and therefore react to basically every keystroke, but there also is the on change event, which basically does the same here. It will also trigger on every keystroke, but the advantage of the on change event is that we can, for example, use that same event for all input types, for example, also for dropdowns. So here I will add on change this event listener to this input, or this prop to this input. And under the hood, this will then add an event listener for the change event to the input element, which is rendered in the DOM. And then we need to point at the code, at the function that should be executed when that event occurs. Now you learned that we can define it inline here with a function or with an arrow function, but that it's better to define it up front, and therefore that's what I'll do. I'll add a new const and name it title change handler to make it clear that this will be called upon an event. I end with handler, and I'll name it title change handler because this function, which I'll store here, should be executed whenever this, well, title input changes. So here, for the onChange prop, I'll pass a pointer at this title change handler, so at this function here, as a value. And again, we don't execute it here. We don't add parentheses. We just point at this function. And this, if I console log now, will now execute whenever we type in this title input field. So if we go back and open the developer tools, if I type here in the title, you see title changed for every keystroke I do. Now that's great, but typically we want to get the value the user entered. And the question now is, how can we get that value? Which possibilities do we have here? And the answer is quite trivial, at least if you know vanilla JavaScript, so JavaScript without React. If you would add an event listener to some element in vanilla JavaScript like this, then you would listen to, let's say, the click event, and in the function which you pass as a second argument, which by the way is basically the function you pass as a value to this prop, there you automatically get an event object which describes the event which occurred. That's a default JavaScript behavior you get in the browser when you listen to events. And we get this default event object here as well, automatically. We don't need to do anything to get this. Since we pass this function to React basically through this onChange prop, React will make sure, or actually even the browser itself will make sure, that we get such an event object when this change event occurs. Now we can log this object to see what's inside it. So I'll log this event argument, and if I now reload and I start typing, I get this object here. And this object has a bunch of data. The interesting thing for us is this target field here. This target here simply points at the DOM element for which the event occurred, so in this case, this input. And this input element, in turn, has a long list of properties which we can read and set. But most importantly for us, it also has a value property. And this value property holds the current value of this input at the point of time this event occurs. And that's super useful, because that means that we can drill into this target and then this value I just showed you to get the value which was currently entered when that event occurred for that element on which we're listening. So now if I reload, you see that I get the current value with every keystroke. And that's super useful. Now we got this value. The question now is, what do we want to do with that value? What's the goal now? And the answer is, well, we want to make sure that we store it somewhere so that when the form is submitted, we can use that value. Because of course we want to gather all values for all inputs and then combine them into an object when the form overall is submitted. And one way of storing that value and making sure that it survives, even if that function would be re-executed for whatever reason, so this component function I mean, to make sure that we store the value and that it survives if that function would be re-executed and the component would be re-evaluated, we can again use state. So we can import the use state hook from React here and basically just call it here at the beginning of the expense form function and set the state for this input here, so to say. And initially that's an empty string, because initially when this component is rendered for the first time, nothing was entered. But then we can again use destructuring to get our two elements, which is the currently entered title, maybe we name it entered title, and a function for updating the state, which, following the convention, should be named set entered title. And here, when we react to this event where the user enters something, we can just call set entered title and pass event target value, so the currently entered value, as a parameter, as an argument, to set entered title. And therefore this will be stored in our state. Now here I'm not really doing it to update this component, though the component will update. That will always happen when you update the state, but I'm doing it to ensure that we're storing this in some variable which is kind of detached from the life cycle of this component function, so that no matter how often this component function might execute again, this state is stored and survives. There would be other ways of solving this as well, but that works just fine. And it has another advantage, because we'll need that state for updating and for re-rendering that component later anyways. But for the moment, we just use it to save the value. Now we can do the same for the other two inputs, and of course definitely try this on your own as well. Pause the video and make sure you listen to these change events for the other inputs as well, and that you also store state for those changes. So here's your chance to pause the video. Thereafter, we'll implement this together. So, did you add that? Let's now do it together. And I'll start by adding a new function, and that will be the amount change handler. And the logic is basically the same as before. I want to make sure that this function gets triggered whenever the amount changes. So on the amount input, we can add a onChange prop and point at the amount change handler just like that. And before I add any code in there, I will already add the third function for my date change handler, like this, and that should be triggered whenever the date changed. So here I also listen to onChange and point at the date change handler. So now all these inputs are wired up, but of course at the moment nothing is happening here. Now I also of course want to store state for changes made here, and that brings up one important question. Maybe a problem you also encountered. How can you manage more than one state? It is something we haven't learned up to this point. But it turns out that it is rather simple. You can call useState more than once. Maybe you tried that, and if you did, good job, because you can do that. You can have multiple state slices or state pieces per component. And all these states inside of one and the same component will then also be totally separated from each other. So here I'll call useState again and extract my entered amount and my set entered amount function with array destructuring. And now we got these two pieces of state which belong to this component. And we can update and read them individually, so they work in a totally separated way. When I update the amount, this will not affect the title, and vice versa. So for the amount change handler, we can call setEnteredAmount and pass in event target value here as well. Well, and unsurprisingly, we can do the same for the date. Call useState again and store an empty string here as well. By the way, I'm storing strings all the time and not a number here for the amount, for example, because by default, whenever you listen to the change event for an input, if you read the value of that input element, it'll always be a string. Even if it stores a number, it will be a number as a string. And the same for the date. So we always get a string here. That's why I also initialize all states with a string. And here, therefore, for this third state, I have my entered date and set entered date. And I now also can update this state here with set entered date event target value, like this. Okay. Now we got these 3 state slices, and this is really important. This is absolutely okay, and you will see that quite a lot, that you have more than one state per component. You can have these separate states and update them separately and manage them separately. That is a key part of this entire state concept React ships with. You can and you often will have multiple states per component. Nonetheless, this multiple states versus one state thing is a concept I want to take a closer look at. So in the last lecture, we added these handler functions and we added multiple state slices. Now I did emphasize that you can have multiple such slices, that this is totally normal. However, there also is an alternative, and it depends basically on your personal preferences, which approach you prefer. You can have multiple slices, but you could also argue that of course all 3 states here are related to our form. That in all 3 states we just store some user input, and that it's therefore basically the same concept repeated 3 times. Therefore, you could also go for one state instead of 3 states. How? Simply by commenting this out, by calling useState only once, and by passing in an object as a value. And that's important, not a string or number or anything like that, but an object. And of course, in this object, you can now group together your 3 states. You could have a title key, or maybe also an entered title key, and that holds an empty string initially. And you have an entered amount key as well with an empty string, and an entered date. So the logic is kind of the same, but now it's in one state object managed as one piece of state instead of 3 separate slices. The difference now, of course, is that whenever you update this state, you need to update all 3 properties and not just one. So here you could then also extract this and have your user input, for example, and set user input. And now when the user enters a title, you wouldn't store it like this, but you would call set user input. And in the end here, you then want to pass in a new object where you set the entered title, in this case, to event.target.value, but, and that's now the tricky part, where you also ensure that the other 2 pieces of data don't get lost. If you would just set your new user input state to this object, you would basically dump the other keys. Because when you update your state, React will not merge this with the old state. It will simply replace the old state with the new one. And if your new one is an object with 1 key value pair here, the old state will be replaced, and therefore the other 2 key value pairs for amount and date would be lost. So if you go for this one state approach and you manage such an object, it's also your responsibility to make sure that the other data does not get lost. And to do that, you manually need to copy the other values which you're not updating here. So if you are updating the title, you also want to copy in the existing values for amount and date. And one way of doing this would be to use the spread operator, which is a default JavaScript operator in modern JavaScript. And you copy in user input like this. Actually, you do this first. And then you just override entered title. If you haven't seen this syntax before, this in the end just takes an object, pulls out all the key value pairs, and adds them to this new object. And then we can still override key value pairs, like in this case, entered title. And by doing it like this, we ensure that the other values aren't thrown away, but are also part of that new state. And now we could do this in all 3 places here, of course, and update the entered amount here, and do the same here, just that here we update the entered date. And that would be an alternative to having the 3 individual state slices. It's up to you what you prefer. And this code also isn't perfect yet, by the way. I'll come back to this in a second. But generally, you can switch between these approaches. Now, I tend to prefer the individual state slices. And I would say you also see that more often out there in the wild, in other React projects. But ultimately, both approaches are fine. One thing is not fine, though, and that is how I update my state here when I also consider my old state for copying in values. And that's something we're going to take a closer look at in the next lecture. So in the last lecture I showed you how you can use one state instead of multiple states, and I did talk about it there. Now the way I'm updating my state here is not entirely correct though. It technically would work, but in niche cases it could fail, and it's simply not a good practice to update it like this. So what's the problem here? Here, I'm depending on my previous state for updating the state. In this case, we depend on the previous state because we use this one state instead of 3 states approach, and we need to copy in the other values so that we don't lose them. Hence, we depend on the previous state snapshot to copy in the existing values and then just overwrite one value with a new one. Now, whenever, and that's another key rule which you should memorize, whenever you update state and you depend on the previous state, so for example, as we do here in this object, but also if you would be managing a counter which you increment by 1, for example, whenever you update your state and you depend on the previous state, you should not do it like this, but you should use an alternative form of this state updating function. Instead of calling it like this, you should call it and pass in a function to that function. So you call the setUserInput function and you pass a function to it. For example, such an anonymous arrow function. And this function, which you pass to setUserInput here, will automatically be executed by React, and it will receive the previous state snapshot for that state for which you're calling the updating function. So in this case, for this object state here. So we'll get the previous state snapshot, and now here we should return the new state snapshot. So instead of this function which we pass to the state updating function, we return the new state now. And that now could be, or in this case should be, our object, where I copy in the key value pairs from the previous state with the spread operator, but where we then also override, in this case here, entered title with event target.value. Now, why should we do it like this instead of like this? In many cases, both will work fine, but keep in mind that I mentioned that React schedules state updates. It doesn't perform them instantly. And therefore, theoretically, if you schedule a lot of state updates at the same time, you could be depending on an outdated or incorrect state snapshot if you use this approach. If you use this approach, React will guarantee that the state snapshot it gives you here in this inner function will always be the latest state snapshot, keeping all scheduled state updates in mind. So this is the safer way to ensure that you always operate on the latest state snapshot. So you should use this function syntax here whenever your state update depends on the previous state. That is something you should memorize. If your state update depends on the previous state, use this function form. With all of that though, I wanted to show this because these are key concepts, which you're also going to see again and again throughout the discourse and throughout a lot of React projects. But here, I will actually comment out all of these alternatives, and I will switch back to that multiple states approach instead, which we initially had. So let's comment out all of that and go back to this initial approach. I just wanted to show the alternative because it is a valid alternative. You will see it in many projects. You will have scenarios where you need it. And this thing regarding the if you depend on the previous state, use this approach thing here, that's something you should keep in mind in general, because you will often depend on a previous state, not just if you merged state like this, but also in other scenarios like the counter, which I mentioned, for example. So that's why I mentioned this. Nonetheless, let's go back to this multi-state approach now. Now, we spent a lot of time on this state here, and I showed a lot of alternatives, but up to this point, of course, we're not doing too much with that state. That's what I want to change now, though. Now, I want to make sure that this form can be submitted when this button is pressed, and that then we basically gather these different state slices here and combine them into one object, which for the moment is then just logged to the console, but which we can use for different things later. And therefore, we want to listen to the form being submitted. Now, we could add a click listener here to this add expense button, but this would not be the best way of listening here. Because indeed, there is a default behavior built into the browser and built into forms on web pages. If a button, especially with type submit, is pressed inside of a form, this overall form element will emit an event to which we can listen. And that's the submit event. So it's on this form where I want to react to on submit and then execute some function whenever this form is being submitted. Now that's a function I'll add here, and I'll name it submit handler, like this. And then here we just point at submit handler as we did it for all the other events as well. Now the thing here is that I just said that this is a default browser behavior, and unfortunately a part of this default browser behavior is that if you do click this button, the page reloads. because the browser actually automatically sends a request whenever a form is submitted to the server which is hosting this web page. So in this case, to this development server. And that's not what we want here. Instead here, we want to handle this form submission with JavaScript and manually collect and combine the data and do something with it. Thankfully, we can disable or prevent this default behavior, because we again get an event object here automatically, just as for the change events. And on this object, we can call a prevent default method. This is built into JavaScript, nothing React specific. This is default JavaScript behavior. We can prevent the default of this request being sent. And since that request is not sent, the page will now also not reload, because we stay on the currently loaded page without sending any request anywhere, and we can continue handling this with JavaScript. So therefore now we can create our, let's say, expense data object here, and now combine all that entered data. Of course, if you used this one state instead of three states approach, you already have such a combined object. But I don't have that here, so I will now create it once the form is submitted, and simply add a title here, and set this to the value stored in the entered title state, add an amount property, and set this to entered amount, and a date property, and actually set this to a new date, constructing a new date with the built-in date constructor, to which then in turn I pass the entered date, which will parse that date string and convert it into a date object. Now these property names here, title, amount, and date, are up to you because this is your object. This here, of course, entered title, entered amount, and entered date, points at these state variables, so to say. If you used the combined approach, you also might want to remap the property names, because later in the app I will rely on having a title, amount, and date property name. So make sure that these property names exist and hold the correct value. And then for the moment I will just console log expense data, so that we can see that. Now if we reload this and enter test and $12.99, and then pick some date here, if I click add expense, that's looking good. We got this object which has all that data stored. So this now also works, and we are reacting to the form submission. Now I also want to clear the inputs to delete the entered values when that form is submitted. How can we clear those inputs? Well, that's part of the reason why I wanted to use state for storing the entered values. We could have also used the global variables outside of the component function otherwise, if we just wanted to persist the values, but by using state we have an advantage. We can now implement something which is called two-way binding, which simply means that for inputs we don't just listen to changes, but we can also pass a new value back into the input, so that we can reset or change the input programmatically. And how do we do that? Well, it's very simple. All we have to do is add the value attribute, which is a default attribute, to this input element. This will set the internal value property, which every input element has, and we can set it to a new value. And here I will bind this to entered title. So now this is two-way binding, because now we don't just listen to changes in the input to update our state, but we also feed the state back into the input, so that when we change the state, we also change the input. This might sound like an infinite loop, but it actually isn't, so we won't have a problem there. But the advantage is that when the form is submitted, for example, we can call setEnteredTitle and set this back to an empty string, which also was our initial state. And by doing that, we override what the user entered after the form was submitted, and therefore clear the input. And we can do this for all inputs. We can set the entered amount to an empty string, and set the entered date to an empty string, and then just add the value prop to all these inputs. So here I add value and point at entered amount to pass that back into the amount input, and do the same here for the date. Pass the entered date back into the input. If we now save that and I reload, this is looking good. Now we can still enter something here as it seems, but if I click add expense, you see it's all cleared again. And we still have our data collected and stored here in this object. So this is a neat behavior, but more importantly, this is also another key concept in React. Two-way binding is very useful when you're working with forms, because it allows you to gather user input, but then also change it, for example, upon form submission. Now, with the changes we made over the last lectures, we are able to gather our expense data, our user input, and combine it into this object and clear the form thereafter. The only problem is that having this data is nice, but we technically don't need it in the expense form component, do we? Instead, we need it in the new expense, or to be precise, in the app.js component even, because there we have our expenses array, and ultimately our goal will be to add this new expense which the user entered to this list of existing expenses. And we probably also want to enrich it by adding an ID. So we need to pass the data which we're collecting and generating in expense form to the app component. Now, up to this point, we only learned how we can pass data down. So how we can, for example, in the expenses folder, pass the title, amount, and date from the expenses component to the expense items component. So from parent to child. That's something we learned. We can do that with props. But how can we do it in the other direction if data is generated in the expense form and we then want to pass it up to the app component? Well, actually, we already saw how it works, but it's easy to miss it. So let me show it to you again. In expense form, we are listening to user input, to changes to the title input, for example. And whenever the user types there, this function, title change handler, executes, and there we get this default event object. That's something the browser gives us. Now, actually, we can think about this input element here as a component as well. It's not one of our components, but it is simply a pre-built component, we could say, provided to us by React and of course translated to the input DOM element. But it has this component character in the end. And we do also set some props on that component, including this special onChange prop. Now actually, this onChange prop isn't that special, it's just a prop named onChange, which wants a function as a value. And then internally, the input element adds this event listener. So React basically sees that we set a value on this onChange prop and adds that listener on the rendered input element. But that is a pattern we can replicate for our own components as well. We can create our own event props, if we want to call it like this, and we can expect functions as values, and that would allow us to pass a function from a parent component to a child component, and then call that function inside of the child component. And when we then call a function, we can of course pass data to that function as a parameter. And that's how we can communicate up, from child to parent. Now, in case this was too quick, let me simply show it to you. Let's say we want to pass the expense data, which we gather in the expense form component, to the new expense component as a first step. Because if we ultimately want to reach the app component, we first of all have to reach the new expense component, because it's the new expense component which uses the expense form. And then in a second step later, it's the app component which uses the new expense component. but we can't skip components in between. That's also something you learned in the previous course section. Props can only be passed from parent to child. We can't skip intermediate components. So therefore, as a first step, let's make sure we can pass the expense data to new expense. And we can do this by adding a new prop to expense form. It's our component, so we can name it however we want, but I will name it on save expense data. But the name is totally up to you. I'm just naming it on something because I want to make it clear that the value for this prop should be a function which will eventually be triggered when something happens inside of this component. In this case, when the user saves the entered expense data, so when the form is submitted in the end. So that's again a convention I'm following. You don't have to name it like this. You can name it however you want. It's totally up to you. It doesn't have to start with on. I just do start with on to follow this convention and to make it clear that the value for this prop should be a function which can then be called inside of the expense form component. Hence, it's a function we should define here in new expense, just as we did it for the input elements with the functions we bound to the onChange prop. We defined those in the expense form before we returned the JSX code as well. Now we're doing the same here, one level above that in the new expense component for our own custom expense form component. So here I'll add a const save expense data handler, and important, as a parameter here, I will expect the entered expense data. The name of the parameter is up to you. It's your function, but now I make it clear that this function expects to get this parameter. And then here we can add our expense data, another object, copy in the entered expense data, which I expect to be that object which we generate here in the submit handler, so this object. I pull out all the key value pairs and add them to this new object, and then I add in a new key, the ID key, and simply set that to math random toString to convert it to a string. It's not a perfect unique ID. Theoretically, we could generate the same value twice, but it's good enough for this demo. And then we can see what we do with that thereafter. For the moment, I'll just log this enriched expense data. Now it's a pointer at this function, which I want to pass as a value to onSaveExpenseData. So that this onSaveExpenseData prop in my custom component receives this function as a value. Again, I don't execute it here. We don't add parentheses. I just point at the function so that the function itself, a pointer at it, is passed to expense form. Now that's the first step. The second step now is to use this function inside of our custom component. That's a step we didn't have to do for the inputs, because these are built-in components basically. But there also, we pass a function to onChange, and internally React then will add a listener and call this function which we pass in whenever that event occurs, that change event. Now, since we're doing this on our own custom component, we also have to call the passed in function manually. And that's what I'll do next. So inside of expense form, we now can expect this onSaveExpenseData prop because I am setting it when I use the expense form component. Hence, inside of expense form, we can extract the value passed for this prop, i.e. this function. So, inside of expense form, I of course now expect to get some props, because we're setting a prop now. And now inside of the submit handler, instead of logging my expense data, I will access props onSaveExpenseData and execute it here. And that's now important. Now I execute it. I can execute it because the value which we get on this onSaveExpenseData key will be a function. We are passing in a function here after all. So it's this function defined in the new expense component, which we will now execute in a different component, inside of expense form to be precise. And we can execute the function, even though it's not defined inside of expense form, because we are passing a pointer at it through the onSaveExpenseData prop. And this is a super important pattern which you will use a lot in React. This is how you can communicate between components and how you can communicate up. How you can make sure that a child component, the expense form component here, for example, can communicate up to the parent component, the new expense component in this case. We can call a function in the new expense component, and we can pass data as a parameter. So here, when we call onSaveExpenseData in the expense form, I can pass the expense data which I generate here as an argument. And that's the value which we'll receive as a parameter here in new expense. I hope this flow is clear. The trick really is that we pass around a pointer at a function. Now if we go back and I reload, if I again enter something here and pick a date, if I click add expense, you see this is being logged to the console, and it's being logged from the new expense file line 12. So it's this log here. And we can tell that it's from there because we also have an ID field there, which has this random number which is generated and converted to a string. And that's how we can communicate up. And this is a super important pattern. Now, of course, we can continue in this chain now. And we can communicate up from inside new expense to app, because it's this app component which needs the new expense in the end to add it to this expenses array. So therefore, again, in app.js, we can add a function which we defined before we return JSX code, and we can simply name this addExpenseHandler, and we expect to get our expense here as a parameter, and then we do something with it. And for the moment, I'll just console log in app.js and console log the expense, because we haven't quite yet learned how we can render lists of data dynamically. And therefore, for the moment, I will not update the expenses array. That is something we'll do and learn about in the next course section though. For the moment, I just want to confirm that the data arrived. So here's the function. Now again, using the same pattern as before, we can pass a pointer at this function to new expense, so that inside of new expense, we can call this function and pass that expense data up to the app component. So we could name this prop here onAddExpense. Again, the name is up to you. It's your component. But again, I will follow this convention, starting with on to make it clear that it's a function pointer, which is passed as an argument. And then I pass a pointer at addExpenseHandler to the onExpense prop on new expense. And therefore, inside of new expense, we can now call that. We can accept the props argument here as well, this parameter. And in SaveExpenseDataHandler, which itself is called when something happens in the expense form, we can of course now also call props on add expense. And of course here we want to use the name which we chose here in the app component. We're calling the function passed as a value for that onAddExpense prop. I'm calling this here, and I will forward my enriched expense data here. And if we now save everything, again, if I reload and I add a book here for $12.99, if I click add expense, this is being logged from inside the app component, as we can clearly tell. And I'm actually logging the expenses as I see. I wanted to log the expense instead, so let me fix this. Let me give this another try. A book, $12.99, pick a date. Yeah, so now we're logging the single expense. Again, we'll use that expense and change the array and output the array dynamically too. We'll do that in the next course section. But for the moment, I wanted to focus on that state and event handling thing. And being able to pass data up is a crucial part of that. And here's how it works. In the last lecture, we learned about a very important concept of moving data from a child to a parent component by utilizing props to receive a function from the parent component, which we call in the child component. And this is closely related to another key concept which we also already used without even knowing. And that's a concept called lifting state up. Now, what is that about? Consider this basic component tree, which is roughly what we have in this demo application, where we have an app component, which in turn renders an expenses and a new expense component. Now, in this case, the new expense component is a component which generates some data, some state. In our example application, we are fetching some user input here. Now, it is quite common that you do generate or fetch data in a component, but that you might not need that data in that component. Instead, we need it in another component, in the expenses component. That's where this generated data is needed in the end. Slightly transformed, packed into an object, but it is the data we fetch in new expense. So naturally, we would like to hand that data over. But that doesn't work like this because we have no direct connection between two sibling components. Instead, as you learned by now, we can only communicate from parent to child and from child to parent. That's why in such cases, like we have it here, we utilize the closest component, the closest parent component, which has direct or indirect access to both involved components. In this case, the app component. The app component in our application has access to both the new expense and the expenses component because it renders both components in its returned JSX code. That's why we want to utilize that, because we can now store our state in that closest involved component, so in that parent component which has access to both involved components, by lifting our state up. So by passing our generated state data from the new expense to the app component. And that's what we're already doing in this demo application. We're doing this by utilizing props, by calling the function we receive on the onAddExpense prop. That alone is not lifting the state up. That's just calling a function we receive through props. But then we do something important. We actually do pass data to that function which we call here. We pass the expense data to the function we receive on the onAddExpense prop. So we're passing data to that function, and by doing that, we're lifting that data, that state, up. We're not keeping it in the new expense component. We're not keeping expense data there. Instead, we are lifting it up to the app component so that in there we can use it. Like an addExpense handler, where at the moment we are logging it to the console. Now we're not yet managing that data as state here. Instead, we're just logging it to a console. But in the next course section, we are going to manage this whole array here as state, and we are going to add the expense to that array. And we are already passing down that array to the expenses component. Because that's the other part of this lifting the state up concept. We are lifting the state up, we are passing data up to some parent component, because we either need that data directly in the app component, or, as it's the case in our demo application, and as it is quite common, because we then want to pass that data down to another component via props. That's what we did in the last course lecture, And that is an important concept. You will hear the term lifting the state up quite a bit when you're working with React, also later in the course. And whenever you hear that, it is about moving data from a child component to some parent component to either use it there or to then pass it down to some other child component. And as a side note, this does not just work if you have the app component which interacts with two direct child components. Instead, in this example already, the new expense component is actually not the component which generates the data which we're passing up. Instead, it's the expense form component which generates that data. It's that component which works with state and which fetches user input and stores user input. And that component then passes up that fetched data to the new expense component. So here we are already lifting state up. And then we're lifting it up even further to the app component, since it's the app component which is then the first component in line, which does not just have access to the new expense and expense form component, but also to the expenses component. And since the expenses component is the component where we need the data in the end, it is the app component where we want to lift our state up to. Now, as you will see throughout this course, it's not always that root app component to which you want to lift your state up. Instead, the goal is to lift it up just as high as necessary in your component tree until you have a component which has both access to the components that generate data as well as the components that need data. That might be the app component, but that could also be another component. Again, you are going to see this quite frequently throughout this course. Now that's it for this section. In the last section, we again implemented two-way binding as part of the assignment. Actually, it was a bonus section of the assignment, I would say. But again, we added two-way binding and we did something which has an official term in React, which I don't want to hide from you. We created a controlled component. And it's not the first time we did that. Basically, whenever you use two-way binding, you are controlling a component. But here we're controlling our own custom component. Now, what does this mean? It means that a value which is used in the component, like the value selected in the dropdown, is passed on to a parent component through props and is received from the parent component. Both the currently set value as well as the function which in the end handles the selected value is not part of expenses filter. Expenses filter is really just a component that presents the UI, that presents the dropdown, and then attaches a couple of listeners or props. But the real logic resides in the parent component. And that turns expenses filter into something which is called a controlled component. Now, technically, there is no difference. Expenses filter is still a regular component as you learned it. It's just a special term that when you see it, basically means what I just explained, that both the value as well as changes to the value are not handled in the component itself, but in a parent component. This component controls the expenses filter component. And that's just a term which you should be aware of. Another term or another concept you should be aware of, because you might hear it from time to time, is about presentational versus stateful components, or stateless versus stateful components, or dumb versus smart components. There are a lot of terms for that. But what do they mean? It simply means that in basically all React apps which you're building, you will have a couple of components that manage some state, like this expenses component, which manages this filter state, or the expense form component, which manages the input state. And then you will have other components which don't manage any state, like expense item, if we remove the button, which we should do because it was just there for demo purposes. If we remove it, We can also remove the use state call, and we should remove it. We can also remove that and that. And if we do all of that, and we set this here back to props title, then this is a stateless component, as it should be. This component is a stateless component, also called presentational or dumb component, because it doesn't have any internal state. It's just there to output some data. And in most React applications, you will have more presentational and dumb components than smart or stateful components. So even though dumb might sound negative and it might sound like stateful components are better, that's not the case. These are really just terms, and typically you end up with less stateful components than with stateless components. Because you want to split up your application into small reusable pieces, and most pieces, most components, indeed will only focus on outputting something, on having some JSX code, maybe some transformation logic like this here, and maybe some CSS code. But it's only a couple of components which typically do manage state. And then this state is spread out and distributed through props in the end. Like here in the expenses component, where we manage the filter state, and then we pass the filtered year, so this state value, through props back to expenses filter. This is a standard pattern which you'll see a lot, that you manage state in a couple of components, and then you might pass that around to other components. And that's basically it for this module. What you learned here, again, was super important. So make sure it's clear to you, make sure you understand what state is and how you can handle events and how you can pass data from a child to a parent component. And with all of that, combined with the course section before, where we covered components in general, we're now prepared to dive into the next course section and basically conclude the hardcore of React basics. But the next section again will be super important because it will be about lists and conditional content.